the names of everybody. You are 14. I need to get all the names, so that it will help me to do what I want to do. So if I can have
Yes,
that
I'm here,
list.
bro. I'm here,
Aha,
bro.
great. Please help me to compile the list of your colleagues and yourself, of course, so that I can do what I want. See what I will do to distribute it to different markets, and then we do that assignment. We need to have it done at least before the end of this month. But we are doing well in terms of coverage. I think soon we will be able to, because now we are going to tackle the post-harvest technologies for extension of the shelf life of fresh produce. Then later on, we shall tackle the post-harvest technologies for the cereals, legumes, and oil seeds. Then I think our last topic will be on minimally processed plant products. The rest will be just notes shared for your own future reference and everything. So that's why we want to do. We want to make sure that we do that assignment um, before the end of this month. Okay, so service technologies for produce. Now, we ended we have discussed remember where we have discussed issues with the factors which cause post service losses, which was more or less like a review. Then we talked about um, the importance of post service technology, and then of course the nutritional composition of these fresh produce plant products. And then of course we also talked about the anti-nutrients. Now we talked about the safety, which is very, very important as far as the utilization of these plant products is concerned. The naturally inherent safety aspects, and of course even those aspects which are extraneous, which come out from outside as a result of the environment. So now I want to see what kind of technologies are there to extend the fresh fruits and vegetables shelf life, remaining fresh. Remember, this course is not about processing, but we are just talking about post-harvest technology, meaning that the produce has to retain its life. The only thing we will be talking about is the primary processing, on-farm processing. Those are the technologies for the cereals, legumes, and the oil seeds. All right. Okay, so I think we can start. Of course, it is always important that you think about the quality, variety of the produce, and these are very, very important as far as driving the market of these produce is concerned. And the value chain actors have the duty, of course, to satisfy the ever higher quality requirements by the consumer. And for growth to continue, the industry, of course, has to be prepared to adopt a wide range of technologies to enable extended shelf life while maintaining the product quality. Quality is very, very important, as we said. Quality, of course, has to do with the organoleptic attributes of the food, and these organoleptic attributes involve, of course, use of our five senses to determine like the appearance of the produce. Very, very important. That's at a glance, how do you look at the produce? So that's a very important quality attribute. And the texture of the produce, very, very important. Then the flavor, that's the mouth feel. How does it feel when you taste it? Then there is the morphology, which includes the shape. Most of these, when grading most of these produce, you depend on the shape. How does it actually look like? If it is supposed to be round, is it round? If it's supposed to be oval, is it oval? Is it Then physical damage, very, very important. Has it been damaged physically, or it has retained its original, form? Those are very, very important. Then the nutritional composition also taken as some part of the quality aspects. What are the nutrients that can be obtained out of a given produce? And then, of course, now we consider the aesthetic factors, the feel factors. Of course, I talked about the texture. How does the produce feel? For example, when you touch it, is it hairy? Is it rough? Is it, limping? Is it, so the texture is very, very important. And after that, then you consider the safety factors, which we considered previously. So using our five senses, we're able to do even to grade the produce using the required grade standards. And grade standards, of course, give the nature of the produce, with categorizing the produce according to size, shape, color, etc. All those. And you know very well that in Uganda, the body that is responsible for setting standards is the Uganda National Bureau of Standards. So this one has had standards set for anything. All these produce that are traded, on the market, they have got their standards. The only challenge is implementation, enforcement, which is supposed to be done by inspectors. But otherwise, grade standards are supposed to be a common language which is supposed to be used during trade. So if you're trading within East Africa, there are standards. That's why our maize was at one time rejected by Kenya. They said your maize is above 10 parts per billion aflatoxin content, therefore it is not suitable for trade. Moisture content alone is very, very important, as we shall be seeing later. So for grains, the agreed upon moisture content is 13.5%, and that cuts across all ESC member states. So if you're going to trade maize, it must be 14% and below. Actually, it's 13.5 and below. So those are the standards, those are quality aspects which are very, very important. But in order to maintain these quality attributes, there are technologies which must be put in place. And the first one is temperature management. So temperature management is very, very important. Ladies and gentlemen, and the temperature is the most effective tool for extending the shelf life of fresh. We're talking about fresh. When you talk about horticultural produce, we are mainly referring to fruits and vegetables. So why? Because if you are going to control metabolic processes, you manage temperature. If you are going to control the rate of growth and multiplication of microorganisms, which cause diseases, you must play around with temperature. If you're going to manage insects, because they also require suitable temperature, you must manage temperature. If you're going to control all these metabolic processes that involve growth and development, of course, including ripening, sprouting, germination, you must, manage temperature. Why? Because temperature is very, very important, in the assisting the enzymes to increase or to enhance or to catalyze all metabolic processes, of course, including respiration, which you said that is a very important factor of post-harvest losses. So here is an example of hold on, just so sorry. Here's an example of a table which is indicating the effect of temperature. Now, on a non-chilling commodity, we are talking about we talked about chilling injury. You remember very well we talked about chilling injury. And so if you are going to have a non-chilling sensitive commodity, of course, because we are involving a low temperature here, like a 0. If you're going to study the effect of temperature, cooling, especially cooling and increasing in the temperature, you need to have a commodity that does not, suffer from chilling injury. So you can see if you start from 0 degrees C, the relative velocity is the speed which deterioration occur, which is, since it is just a relative velocity speed that may not have any unit C, and then relative, post-harvest life. How many, for example, if you're talking about storage in the days, at 0 degrees C, the rate of deterioration is very low, and therefore the post-harvest, life is also high. It may be maybe 100 days. If you're talking about days, maybe 100. If you're talking about months, maybe months, or hours, maybe 100 hours. And then the percentage loss per day is also minimum, just only one. But you can see an increase in 10 degrees C, the rate of deterioration more than doubles. So you go up to 3 times. See, then the shelf life, of course, also now reduces by a third, up to 33 days, and then the loss per day is also 3%. So if you increase to 20, which is now almost our room temperature, if you are storing, for example, leafy vegetables at room temperature, then the rate of deterioration increases by more than 7 times. And then the shelf life now also reduces by more than 10 times. So this is the biggest problem that we are having. So between 20 and 30 is our normal temperature, like here in Uganda, the ambient temperature. So the rate of deterioration therefore is very fast. That's why our leafy vegetables wilt, the fruits also shrivel, as long as they are not cooled down. So the importance of cooling therefore comes in when you cool to about 10 to 7 degrees C, you tend to extend the shelf life. So this is an experiment that was done using a commodity that was not named, but I think maybe they had so many commodities which are non-chilling, sensitive, and therefore maybe they used to take the average. Okay, so there are several technologies which have been used to manage temperature. The first one is room cooling. I think this is very easy to understand. You just get a room which has been provided with cool, cold environment. Cool, you can see this is more or less like an AC. So they just cools the entire environment, and then you put in the commodity. So the harvested produce is carefully stored in a cool room at temperatures that will not cause chilling injury. That's very, very important, because anything to do with cooling, you must put into consideration chilling or freezing injury. Okay. So, technologists, of course, have already come up with the suitable temperature. If you are storing bananas, or if you are storing potatoes, or if you are storing carrots, or if you are storing apples and whatever, so all these temperatures have already been designed. So you must control the range within which you cool the produce. So this room cooling is very, very important, and it aims at removing both the field heat. If, for example, the produce has been harvested when it is a little bit at higher temperature, when maybe during the hottest time of the day, and then comes along with the heat, or the heat that is produced during respiration. That's the vital heat. So this room cooling will remove the vital heat, to not allow the produce to respire and produce heat, which vital heat also encourages the growth of microorganisms. Yeah. Okay. I hope hope we are fine. Okay. So this is you can see these are bananas which were placed in this cold room. It's a cool room, and this person is taking the records. So there are thermometers which are always placed inside the they are placed somewhere in between. Actually, you have to place the thermometer within the box so that you measure the actual temperature of the produce. Although they are also, they are also uh, thermometers, outside the room, the cool room. You to measure of course, the temperature of the room. But there are also thermometers which are placed in here with probes to measure the actual temperature of the produce. And you can see the produce must be placed on pallets so that even cooling, actually the air can move down below. It can pass through the pallets very easily, and then it rises, and then it goes away with the heat. Just a little bit, gentlemen. Just a okay. Let's continue. So the same thing is happening here. So this room can, like this. I think I took this photograph in South Africa. This was a ripening room for bananas. So inside this room, the bananas. This was a multi-purpose room, so it can cool, but at the same time they can use the ethylene to ripen the bananas. You can see, if you look through this hole, there's that green. I don't know whether you can see the greenish. These bananas are still mature green. They are harvested at mature green stage. So they can be now treated with the known quantities of ethylene, which can, because the ripening of we're using ethylene involves also temperature management. So this room will be placed at a particular temperature, and then there is a known quantity of ethylene gas is flown in, and then it ripens uh, the bananas. Okay, power had disappeared here, but it's back. That's why I was wondering. Okay, so so the other was saying air, during room cooling, air moves like this, and then it picks the heat, and then it goes up. So it is always saturating like this. That's why, as you shall see, packages for fresh fruits and vegetables, are of special consideration. They must have these holes. They must have windows adequate to allow exchange of temperature, exchange of heat. So that's why those are the holes which you see later when we talk about, when we talk about packaging. Even during stacking, there are some gaps which are left in there for air to go through, cool air to go through. So that's room cooling. If we could go to a power house, we will be able to see what I mean by room cooling here. Hydro cooling, cooling with water. It's a very common, phenomenon where it combines both the washing of the produce and also cooling. So this one here is specifically to remove 3D heat. If a produce comes along with with the heat from the field, it is placed in cold water, and that then as it is washed, this cold water is also provided with a disinfectant like chlorine. So it is washed, and also any microorganisms that may cause surface decay are removed. They are actually disinfected. So after this, then the produce goes to conveyors and it is packed and then placed to the cool room for further cooling. However, this method is not suitable for all produce. The previous method is suitable for all produce, but this one here, produce like onions and garlic, you know very well that these are they are first of all chewed. So and then these garlicky, ginger, and whatever, their moisture content is a little bit lower because they are chewed to reduce the moisture content to about to 60%, so that they can be kept longer. Anything above that, then these will sprout. So the water will tend to actually to damage them. Okay, onions you cannot place them in a damp place. Okay, so roots and tubers can be washed, but of course drying is very, very important, like cassava, potatoes, and whatever. But carrots can be actually washed; they can remain fresh. But still, you have to reduce the moisture content, otherwise they will decay. They will rot immediately. So the disinfectant like chlorine is also placed. Sometimes even fungicides can be incorporated. If you suspect that there is a fungal infection which is likely to affect the produce, afterwards it can also be incorporated into water. So I took this photograph in Mozambique, you know, where that exporter was very, very serious, and he was having this very big basin where you would now dump the bananas. So if you are having this kind of technology, you can harvest at any time of the day because you are not worried about field heat. Now, they sometimes instead of dumping the produce in a water like this in a bath or in a basin, you can spray. You can just spray cold water on the produce, so the water can be in form of spraying, and then it actually cools the produce and also cleans it. So with the time, chlorine degrades, the organic materials, there's a way they react with chlorine. So this has got to be replaced, replaced or replaced, or new water has to be changed. Okay. Now there is this forced air cooling. Now this is a high technology, high tech, technology, because it involves cooling the produce very, very fast, more or less like a blast freezer, blast cooling. The blast freezer cools, freezes the produce in less than a second. Everything is already frozen because of the way it is actually made. So even here, what you do, you just get an equipment that produces cool air together with the very fast moving fans, and then to force the produce to cool very, very fast. It just creates a difference in the it just creates a difference in the pressure, within the room and also outside the environment, the produce, and then water just moves out, by uh, uh, just more by evaporation almost. So this one is not recommended for all produce, but it may just be recommended for a produce which will deteriorate very, very fast. Although they say they can be used for all produce, but because it is very expensive, so high value produce, those which you think that it may actually be damaged by high temperature can be actually used for this method. So this is what I was referring to. If this is the produce, in the boxes, here you have got the unit that produces, cold air, more or less like an SC. But this one is, the air is so cold, and then these fans will be moving at a very fast speed, and then they send the cool air around the produce like this, and then air will move, removing the heat, and then the produce cools very, very fast. So the speed at which this one is doing, we are forcing, unlike the room cooling where the, the the environment is just calm. In here, it involves blowing, the air, cold air, to the produce like this, and then it cools the produce from all angles, and then it is cooled very, very fast. So that's the third technology of managing temperature. Now, top icing. I think this one you have seen people cooling beer, cooling sodas, using ice, you just press on top. This is exactly the technology. I saw this when I was in the US, being used for broccoli, cabbages, and I think other produce which are not susceptible to chilling injury. So this is on that they resist a little bit of chilling injury, because you are going to use ice, which ice that starts thawing on top of the container, and then that weight is actually cooled. So the water definitely, by the time it thaws at around maybe 1 degree is so cold. So if the produce is susceptible to injury, it will be damaged. Secondly, if the produce is also susceptible to water, because the ice will thaw, will melt, it is also not good. But what they normally do, just get containers which are resistant to water, put the produce in there, and they put ice in the bags and seal everything together, and then they ship the produce. So by the time the produce reaches the destination, it is cool, it is removed, and then placed in the cool room, and then cooling continues. So you can see this method is suitable for cooling leafy and floral vegetables. The floral vegetables, that's why I talked about broccoli, then cauliflower. These are the vegetables where we eat only the flower part. So and also most of these vegetables, I talked about cabbage. It's very, very suitable for that. So the package must be water resistant. The package itself must be water resistant, even the produce susceptible to water damage. So the produce which are susceptible to chilling injury, like bananas, tomatoes, avocados, passion fruits, these are typically of tropical and subtropical origin. They should not be cooled using this method. So these are the methods for managing the temperature of the produce. Now, what is happening? I'm just going backwards. Okay. Other cooling technologies, of course, which you have seen locally. Now, I took these photographs in Rwanda. These people were cooling fruits and vegetables using this locally fabricated, structure. So in here, there is sand, and then they power water, and then this water is absorbed by these bricks, and then they remain cool, and then they cover with this mattress, which is made up of a sponge, which is also an insulator. So they say produce can remain there for a week or so with minimum water loss. This is our pot, the usual pot, of course. All of us have used these pots, especially when we used to keep our drinking water before the refrigerators were introduced. So this one is an insulator, and once it absorbs the water, it keeps the water in there, and then of course the water is cool. the charcoal cooler. I think some of you have seen it. I remember very well that this charcoal cooler was a very important technology for passion fruit exporters. In the absence of electricity, this structure used to be very good. So here you have got a double layer here of the wire mesh, and also inside there they are wire mesh. Then they put charcoal. See, then they put charcoal in there. So when you pour water in, and then that water is the charcoal absorbs the water. It will remain cool for some time. Not of course very efficient, but at least you can improvise. So this one also took it in Rwanda. They were actually packaging. So this was like a packer house. So in here they would do the sorting around here on this, because the grass also retains a cool environment. So they would do the sorting, and then after that they take it to the cool room. Of course, it does not retain all the temperature forever, but at least for some time, it can 1 week, holding the produce in there, especially vegetables, okra, then there's squash, then etc. In that category, they could actually remain in there for some time without suffering from chilling injury. Even person fruits can remain there without suffering from chilling injury. So this is just improvising in the absence of electricity, where you can actually control the temperature in the cool room. So there is also proper temperature management recommendations, that in the absence of all those methods which we have seen, what can you actually do? First of all, we recommend harvesting produce during the coolest times of the day, so that the produce comes with as minimum heat as possible from the field. This is the field heat, where you can now dump the produce in cool water or spray water or whatever. But if you harvest in the morning, the produce tends to have less of the heat. Now the metabolic reactions will be low. Then storage of harvested produce in a shade, at least put it in the shade, avoid direct heat or sunburn, because direct heat definitely will raise the problems of respiration, ethylene production, etc. And then can also cause sunburn. Loading and offloading produce in shades, to minimize heat injury, at least. But think about the way our produce is loaded, how the matoke, for example, is kept in the collection yards, directly exposed to sun. We are going to see that. Shipping produce as soon as possible, to avoid by shipping, I'm referring to transporting the produce as soon as possible to avoid delays that may lead to heat buildup. An example here, for example, bananas which are transported from Mbarara to Kampala, it's a very long distance of more than 400 kilometers. Sometimes the trucks, get stuck on the way because of mechanical conditions, etc., increasing the number of days, in transit. So there is heat buildup, and once there is heat buildup, definitely all those metabolic processes, including respiration and ethylene production, will increase, and the produce will deteriorate very fast. If it is matoke, it can actually even ripen when it is still on the way. Covering produce with tarpaulin or canvas during shipping to avoid sunburn, that is highly recommended. If you're going to be really to move very fast, it is important. Handle produce with tender loving care. I think this is where we have a serious problem. I showed you people seated on bananas, on top of bananas, people seated on handling the produce anyhow, packaging is anyhow, you see, without any any careful, or without any feelings that this produce is supposed to actually to reach in a fresh form. So it is very, very important that you minimize the damages, to the produce, because these damages make the produce susceptible to ethylene, susceptible to decay, causing organisms and all other effects. The produce is supposed to remain in a sound form during transit and during handling. So these recommendations, cut across most of the developing countries where there is no electricity. At least this is what you recommend to minimize the losses. Definitely, you are not to minimize temperature, to minimize all these effects of post-service handling. Now look at that. This is the collection center that I was talking about. The bananas are just heaped like this without any shade. They are just placed directly in the sun. Sometimes vehicles, if it is a rainy day, vehicles take long to come. The roads are slippery, the roads are bad, so they produce delays here for some time. Remember, once it is harvested, its post-harvest life has already started. So the more it delays, the shorter, the post-harvest shelf life. Just directly in the sun, on bare ground, this soil is full of microorganisms which can actually initiate decay. So the bananas definitely will not last long. And you can also, I think, agree with me. Now, this handling, this is what I was saying. Look at it. This one is a very poor package for fingers because there's no any form of protection. They don't respire, you know. Now they put bunches on top of these, and then on top of that they stand. Eh? I tell you, this country sincerely. Now look at these guys standing on cabbages. These were cabbages, standing on cabbages. So what are all these guys doing here? Redundant. Eh? That's why we are having a serious problem in this country. So many people are redundant. Eh? They don't have anything to do. That's why they steal, they do anything. Eh? So look at this. How do you expect these cabbages to last long on the market? Okay. So this is all about temperature management and as the first technology. Now the second, technology that is very, very important in extending the shelf life of fresh produce is management of relative humidity. Okay. And relative humidity is the amount of water vapor in the air. The amount of water in the air. So the higher the relative humidity, the less the process of transpiration. We saw transpiration as one of the biological factors causing deterioration. So we don't want the water to move from the produce to the outside the environment, drying, wilting, shriveling, whatever. All those can actually happen. So we want to maintain a higher relative humidity. Now, optimal relative humidity requirements for fruits is 85 to 95%. Our relative humidity here is about 70-80%. I'm talking about ambient relative humidity. So because it is a little bit low, if produce are just kept in under our ambient environment, they will lose water very easily to the environment. So you need to raise the relative humidity to 85-95%. For leafy vegetables, you can see even 90 to 98%. This is a very high, humid environment. So for these categories which are cured, you can see the relative humidity is quite low. The tubers, roots, bulbs, ginger, whatever, the relative humidity is supposed to be low because once you raise it and then they pick moisture, they will sprout. So this is very, very important. So you can see playing around with relative humidity can extend the shelf life of the produce. So what are the methods of control of relative humidity? First of all, you can add moisture in form of spray or in form of steam, in form of vapor, to the air by using those humidifiers. In the storage room, so the room must be, strong, and then to allow in, water in form of sprays, in form of steam, but of course cool, to so that the produce can remain, the relative humidity can remain up more than 80%. Of course, it's expensive, but it is worth, investing if especially the produce is for export. So regulation of air movement and ventilation in relation to the produce load in humid and cold storage room is very, very important, but it's also, of course, expensive. Now, only thing you need to know is that, okay, you can sprinkle the produce with clean water during tailing markets. We are going to see this as an example. But if you maintain a proper relative humidity, if you maintain a high relative humidity, you may actually increase the chances for microorganisms to grow because they also need water. So what you need to know, and I want you to put down this, that the relative humidity management goes hand in hand with the temperature management. You need to make sure that the environment is cold if you're going to raise the relative humidity. Otherwise, if you raise the relative humidity and then the temperature of the produce surrounding the produce is also high, the microorganisms will just enjoy. And that's what is exactly happening if you just pack the produce, like a matoke, in these kind of bags where it does not have any ventilation or breathing space. Water will accumulate in there, and then, of course, with an increase in temperature, so decay will be initiated very fast. The relative humidity will be very high inside there, but because temperature is also high, then this will not actually help this the bananas. So they will now decay, they just decompose instead. I hope you get that point. So you can sprinkle water. So I took this photograph in South Africa. This is actually these are leafy vegetables, and this is lettuce. So this one, was being kept, you can imagine, in the heaps. So this facility here, which you see, is the one that it produces the increases the relative humidity in form of sprays, in form of vapor. So all the time we just and it has been regulated. I think there are thermostats or whatever. It has been regulated that once relative humidity goes below a particular percentage or level, then this humidifier will produce vapor or steam, and then the whole place remains very, very, very humid. So this, and it is also cool, despite the fact that there are these lights, but the place is also cool. So it is cool and humid. And then these leafy vegetables will remain fresh for almost 2 or 3 weeks without any problem. Now I want you to compare this with what these ladies are doing, and I'm sure you have seen them using these basins. So they get water and then they put the vegetables in there. There are 2 issues here. The reason why, the 2 reasons why, maybe 2 or 3 reasons why these vegetables don't actually last long, and eventually you see this kind of condition happening. One, the temperature is high. Okay, so if there's no way you're going to raise the relative humidity down there, because when the temperatures are actually high. 2, the nature of the water that is used. Look at these jerry cans. The water that is used is so that it has got all microorganisms, and there's a certain type of bacteria which normally causes this soft rot decay, which is very common, in all these leafy vegetables, the cabbages, the whatever, or these amaranth. So when you pull out a bundle like this, it will be smelling a lot around this area because of that bacteria, the Erwinia bacteria. It causes soft rot decay, and if it is cabbage, because of the sulfur content, the smell will be even terrible. So that's the problem, because there's no temperature management. They're only managing relative humidity. They can sprinkle water here, they can do anything, but the moment you sprinkle water without managing the temperature, you're wasting time. The produce will just decay. Okay, so that's the problem, but you cannot completely deny them this activity, okay, because I mean it is a temporary measure for sure. It is a temporary measure. Once the customers don't come on that day or 2 days, I think if when you go to the market, see, these are some of the factors that you're going to be considering. Now, most of these we talked about the harvesting of these leafy vegetables, the roots, to help them in bundling, but also I think sometimes they believe that these roots help to keep the produce for a longer time, which is completely wrong. As long as you have uprooted and the roots are broken, they don't actually help at all. So is that clear? So this is a serious problem that we're having. So relative humidity is the second technology. The third technology is use of modified atmosphere or controlled atmosphere storage. Now, common air, the ambient air, is made up of oxygen, carbon dioxide, nitrogen, and of course the other whatever, what you used to call rare gases. And the oxygen is 21%, carbon dioxide 0.03%, nitrogen is about 78%, then there's carbon dioxide, which is 0.03%. Yes, I've talked about that. Now, then the other percentages are, of course, those gases, other gases. So, under that kind of circumstance, a produce is supposed to be respiring normally. When the carbon dioxide content is 21%, carbon dioxide, oxygen 21%, carbon dioxide 0.03%, nitrogen 78%, the produce is respiring normally. So once you change, the levels of oxygen and carbon dioxide, you tend to affect the rate of respiration and ethylene production. Think about a situation where you are locked up in a lift. Lifts in the past used to kill people. Power goes and then you're inside there. You don't have access to fresh air. Then you start breathing, so you are increasing the carbon dioxide amount, vis-a-vis the oxygen levels. So time comes when you actually don't have any more oxygen and then you suffocate and you die. So this is exactly the situation that I'm talking about. So a produce, because these produce are actually respiring, they can modify their own. If they are placed in a container that is not permeable to gases, they can modify their own air, and in that way the rate of respiration reduces. So that modification is what we call modified atmosphere storage. But the atmosphere also can just be modified by somebody, a technologist, that is now such that you control the atmosphere surrounding the produce. That's called controlled atmosphere storage. So if you put in a produce, just a minute. Okay, I was trying to explain this technology. So the produce can modify its own atmosphere until an equilibrium is reached, and but also you can now control the surrounding atmosphere by just ensuring that you increase the amount of carbon dioxide and reduce the amount of oxygen. It's just playing around with the respiration, because respiration is a factor that causes losses. So this is the same technology that is used in the management of insects. I don't know that you've heard about pix bugs, where you eliminate all the air and you remain with nothing. No, all oxygen is already eliminated, and you remain with nothing. So the technology involves changing the levels of gases, i.e., removal or addition of gases, resulting in an atmospheric composition around the commodity that is different from that of air. So what are the effects? First of all, it reduces respiration, infection by diseases. Most of these molds which cause decay to our produce are aerobic. Once you exclude the air, once you exclude oxygen, they are gone. Infestation by insects. All insects are aerobic. Once you tamper with oxygen, they also, retardation of senescence through reduced ripening. So there has been found that once you manage respiration, you also, in a way, reduce the rate of ripening, because ethylene production goes hand in hand with the respiration, especially in climacteric fruits. So the ethylene production rates are also reduced, and of course even the softening and most of these compositional changes, since the respiration involves now breaking down of the stored materials, all these carbony materials, the starch, of the carbohydrates, the lipids, the proteins. So that means that you are actually reducing the rate of losses. So reduction of fruit sensitivity to ethylene has also been actually established at the oxygen levels below 8%. So you can imagine reducing oxygen from 21% to as low as 8%, and then you elevate carbon dioxide from 0.03 to about 1%. But it has also its own challenges, because if you allow the produce to respire anaerobically, then it produces what? If the produce respires anaerobically, what does it produce? You can tell me.
It produces carbon monoxide.
Ah, anaerobic respiration.
It produces ethanol.
Ethanol, yes. It produces ethanol. It can also produce these other like acetic acid, aldehydes and whatever, which may induce off flavors. So that's why we are talking about off flavors. So vinegar is acetic acid. Hmm? So vinegar, how it tastes. So it's all these are processes of anaerobic respiration, glycolysis. So there's that problem of ethanol being produced, and ethanol may actually, induce, the process of fermentation may induce our flavors, but also you can also have irregular ripening, because you are tampering with the normal metabolic reactions of the produce. It may not even ripen properly. So after being exposed to this atmosphere, it may now fail to ripen properly. But this is a technology that is used in the US. At least I saw where they are managing it. And then you must make sure that the containers which are being used are impermeable to gases, such that you are able to control the percentages of those gases at the required levels. That's now another technology. So the first technology was temperature management. The second technology is control of relative humidity, or management of relative humidity. Now the third technology is management of the atmosphere which is surrounding the produce. But of course there are other, technologies. Oh, sorry. Now, packaging. Packaging is a very good technology. So it refers to a process of containerization. Exactly, containerization. Packaging is different from packing. By packing, you are you have got units of those packages, and then you're placing them on a container or in a vehicle, on a truck, or whatever, from the Postharvest point of view. But packaging refers now to putting the units of a produce into a package. Okay, into a package. Yeah, so eventually you get the different packages together. So you are protecting the produce from all sorts of external influence, including mechanical, damage, um, uh, water loss, pilferage, stealing, tampering with. eh. So packaging is very, very important in terms of protecting the produce. It facilitates handling, especially during storage and transportation. If you have got in so packages, you can very easily stack them in a vehicle and then transport them properly, rather than doing this what we call bulk packaging, like the way we normally transport matoke. It helps to control this quiescent infection. I talked about it when we were talking about the factors which cause post-harvest losses. This is now the quiet infection. If you have seen it, or for example, apples which are packed in trays, like they are like a trays of eggs, each fruit in its own, cell, so that they don't rub against each other. You can very easily control this infection, where one infected fruit can infect the neighboring fruits. So that's a very good technology. Packaging facilitate temperature, relative humidity, and the three management processes. Yes, we have already seen that when you have packed the produce, and then these packages have got the holes and whatever for facilitating air movement. So we have got primary packages, secondary packages, and tertiary packages. What is a primary package?
I think it's that package which, like, the food is in direct contact with it.
Yes. So this is exactly the thing. Yeah, it is the one which is in direct contact with the food. So this primary package should not react with the food. So it should be able to not react with the food, should protect the food. Okay. Otherwise, if it reacts with the food, like if it is a metal, if it is if it is a metal can, it must be coated with the a layer that is not reactive, that is actually inert, not reactive. Otherwise, if it reacts, it may produce all sorts of other compounds which may be dangerous. Then the secondary package will contain hints of the primary package. Like now, beer crates. The beer bottle is the primary package. You put it in the crate is the secondary package. Then tertiary packages, so like the crates now can be placed in a larger, for example, container, and then they may be transported. So these are now larger, the tertiary packages are larger, packages, because they contain units of secondary packages and also the primary package. So all these are just helping to offer further protection and ease of transportation and handling of the produce. So you can see these are the most commonly, containers for fruits and vegetables. The corrugated fiberboard containers. They're just made up of actually paper, which is in form of layers. You can see these, corrugations. What is the purpose of these corrugations? Yeah. So like this one now has got these corrugations are just here. So why are they? Why? What is the purpose?
Maybe it's like cushioning.
Yes, they offer the cushioning effect, such that because these are going to be stacked, and when the vehicle is moving, they tend to they are like springs. They are they cushion the the produce. And you can see inside they are very smooth. Actually, if I wish I had the way of unpacking this and then demonstrating it, has got, this is down area. You know that you can even sit on this, because these ridges, the edges are very, very rigid, very, very strong. Okay, so you can have these, paper boards. uh, okay, you can also have these plastic crates. They're also very common. But look at the holes. As I was saying, these holes are very, very important to facilitate cooling. These ones here, they are not just for formality. And then they should just be random. They are also calculated. Otherwise, if you put so many of them, the produce will lose water, which you don't want. So see, look at these tomatoes. So in developed countries, most of these fruits, they don't remove the calyx, the stem end, because once you remove it, you facilitate the entry of microorganisms. But ours here, we do that. But here they just cut around this area, tap, and then the calyx goes along with it. That's why you have seen the apples sometimes having this stem end. So you see these strong ridges which can resist the stacking pressure. So you can put boxes on top without any problem. These are very strong. But of course, even the cushioning effect is also provided. Okay. Now these are strawberries. I took this photograph in South Africa. Now strawberries are very, very, very delicate. So you can see now they even provide an extra lining which is made up of I don't know this. It's like what? It is a poly something, but very, very soft. And then you have to see to make sure that these holes left there for respiration and temperature management, because these ones are highly respiring. They are climacteric. They are very, very tender, and then produce a lot of ethylene, so it has got to be removed. That's why actually these do not stay on them for a long time. In fact, packaging for this is even done in the field. As you clean immediately, put in the container. Otherwise, you cannot manage to wash them or handle them like the way they handle bananas, etc., because they are very tender. These are pineapples. You can see this, stacked together, the boxes. Why our pineapples are so good here, very, very nice, very delicious. But unfortunately, the size is too big. So for the export, you can imagine how many pineapples you can put in the box like this one. So like here, these pineapples are tiny. Yeah, so you can put 5 of them in a box and then stack the box like this and then transport. How many of our smooth cayenne variety can you put? So that's why in most cases we don't take them very far. So if you are to export, they take those medium-sized ones. The larger ones are always left for the local market. So the medium, the small ones are the ones which are taken. But unfortunately or apparently, they are of the poor quality. Their taste is not good. But of course, these guys don't care, because for them they eat these as salads. So for us, we want to eat a pineapple, and when you're eating a pineapple, you are eating a pineapple. But these guys eat these as salads. So these are small ones which may be a little bit even bitter, but they don't care. Cantaloupes. I don't think you have seen cantaloupes. Some of you may not have seen cantaloupes. They taste like a pawpaw, but very nice fruit. They are actually melons. So you can see how they are being sold. This was in South Africa. This was a little bit of the disorganized market, where they even had to cut this to show the buyers that the nice fruits and whatever. Otherwise, if you have harvested at the same quality, same time, there's no need of even cutting or showing this. This is what I was talking about. So this kind of packaging is very, very good. You can see you can prevent the rubbing, the rubbing of fruits. And this rubbing may cause two problems. One, of course, it may cause surface injury, the scratching, the in-pack movement, called this in-pack movement. Or if this is diseased, it may actually affect the neighboring the neighboring fruit. So by doing this, you can prevent latent infection. This is what I was saying, so that they don't actually, come into contact with each other. So all these are technologies, different technologies. This is poly something. It is expandable. Yeah. So these are pepper chilies wrapped in this kind of plastic sheet, but of course it has got tiny micro pores, tiny pores that allow exchange of heat. It's not completely tight. Now see, because these are already chewed, they are already reduced. They already have reduced moisture content. You can use this kind of package, so they don't have to protect them a lot from physical damage, which you cannot do. You cannot pack tomatoes like this. So these are just plastic bags which are interwoven with all the holes that maximum holes, because we're not worried about water loss in this kind of produce. See, the potatoes can be handled like this, no problem, because they are chewed, they have got reduced moisture content, unlike fresh fruits and vegetables. So this is, I think this is lettuce, yes, packed in this form. These are like cabbages with the cavera and top, but these ones actually we are also in a cool room, as you can see. They are not outside, but they are in a cool room, which together with the other produce. So the relative humidity was high, and of course temperature was also low. Is this packaging?
No.
Yeah, it's not. Definitely it is not. So carrots can be bundled like this and then sold like this. Yeah, but of course not protected at all. Now I took this picture in Rwanda. Much as I was also praising them for being organized. This was terrible. So the way it looks, if you can observe, let me see if I have another picture. Yes, look at the moisture inside. So you can see everything is already. So if you don't manage the temperature, now look at the handling given. So if you don't manage temperature, definitely these carrots, and then you do that. And then after that, you transport like this. I was disappointed. Totally disappointed. See? So how do you expect these carrots to last long on the market? So that's why these are always destined for the local market. But I think we also need to think to strongly think about ourselves. Why is it that we always want to take the poor quality produce, and then the good quality produce is exported? Why don't you also take the best? Because we are also human beings. Now, everything that is poor quality, local market. Poor quality, local market. Why? So anyway, the other technologies which you may read about, curing. What normally happens is that this is mainly for roots, tubers, and bulbs. These ones are placed in rooms where, like, when you talk about curing, in the past we used to know about tobacco, how tobacco was cured. In the rooms where it will be smoked, and then with the increased relative humidity, and then you remove a controlled amount of water from the produce, about 60 to 70%. And once you have cured the produce, can even, if for example there are potatoes, if they are damaged areas, the damaged areas can harden, chew, and then because of the formation of that suberin layer. So you can see browning a little bit. These parts become brown, but they are hard. So diseases cannot enter through there. Moisture content cannot also escape. So through curing, it's more or less like a drying, but controlled, loss of moisture. Waxing, yes, this is a very, very important technology that is actually coming these days, because you see, like apples, they can be placed either in wax or sprayed with wax, but this wax must be food grade. Even the cassava these days, do I have that picture? No, I don't know whether I have the picture of the cassava. I don't have it. So even the cassava these days is waxed. It looks so glossy on top, okay? Glossy on top, and then that waxy also, in addition to making the produce very attractive, it also minimizes water loss from the produce, because it actually blocks those stomachs, where water goes through. Okay, and then also diseases. Sometimes they even incorporate fungicides in the wax, and then you can prevent all the decay, post-harvest decay diseases. But then if you also don't allow the produce to respire through those stomachs, it can also lead to anaerobic respiration. Means that you are actually allow the produce to ferment to produce ethanol, which may now bring about of flavors. But these are the advantages. It prevents water loss from the produce, since it blocks the stomatas. It prevents disease, infection, cutting off entrance of microorganisms, because sometimes they go through those stomachs. It improves glossiness, that's the shiny nature, appearance of the produce, making it more attractive. And then post-harvest fungicides can also be incorporated into it. So heat treatment, actually, this is a very good technology which is used to kill fruit flies, eggs, larvae, etc. So it's more or less like blanching. I went to Israel and I saw a facility which was using hot water treatment for tomatoes, for bananas, for mangoes, even citrus fruits, and they were killing fruit flies in there. They just dip the produce very fast in water whose temperature has been raised a little bit. It is not really hot water, just warm water, blanching, because you don't want to affect the other quality parameters of the produce. Okay, so water can be in form of vapor sometimes, and then it is used. So it controls the insects, fruit flies, the larva, and also sometimes actually it reduces also the pathogens. Because most of these pathogens like bacteria, viruses, fungi, they require just a very very small elevation in the temperature, and then they die. So warm water just kills them, most of them. Although some of them, like the thermophiles, survive high temperatures, but most of them actually die once you elevate the temperature about 30 degrees C, 35, 40 there, and remember, this produce is just dipped there for a very short time. Special chemical treatments, of course, like if you include the potassium permanganate in a package, it can absorb ethylene. Okay, so this is a very common practice for produce which is destined for longer distances. Just like they include silica gel. I think you have seen it in some containers. If you are packing shoes which are susceptible to moisture, they can put small sachets of silica gel to absorb water, from the environment. You can also just put that potassium permanganate. You can also include sulfur dioxide, sulfur, because it prevents most of the molds from growing. Irradiation, yes, it's a technology that I think has been stopped. but it used to be very, very efficient because you use ionizing radiations like gamma, X-rays, UV light to kill insects, and also so it will disinfect. It can disinfect, but also prevent germination or sprouting. So it kills everything. But I think they suspected that these bombarding ionizing radiations may cause, may induce genes which may not be good. So it was suspected that the produce which have been treated like this may actually induce, cancer cells. So it was, I think, stopped. Plus, also, it was not very easy, not very comfortable working with those radiations. If you have ever gone for an X-ray, you know what actually happens. You're always locked in a room, and then somebody who is doing it is also well protected. And because of these radiations, which are very fast moving, you never know what they may actually do to to the person. So it was suspected that they were inducing genes which would actually cause cancer cells. So I think it has been stopped for now, but it was a very good technology. I think we need to stop here. Any questions?
Yeah, I have one.
Yes.
Okay, maybe to go back and we talked about hydrocooling, where they use disinfectants like chlorine and sometimes fungicides. So on these chemicals have any effect on humans? Are they safe? And how much are they supposed to use?
Yes, that's a very good question. Actually, that's why if you are adding their chlorine, you must calculate the amount of chlorine that you are adding. I think if this guy is on I want to find out if Alex Alan is on this. Alan, are you around? Mm, mm. Alan may not be.
He's part of our class, but maybe he's not joined in this one.
Yeah, because he would first of why I wanted Alan to react. He will tell us the amount of chlorine that they put in that water where we dip our feet when we are going to the pilot plant. He knows very well the amount. So for any of the produce, you must use controlled amount of this disinfectant, because chlorine is well known to accumulate in the adipose tissue, leading to cancer. So you must be very, very careful. Much as it is actually used as a disinfectant, we even have chlorinated water. Our water is chlorinated, isn't it? Water from National Water and Sewerage Corporation is chlorinated, but they put there, very, very minimum parts per billion, partially parts per million, I think, with very minimum levels, which may be just suitable for killing the microorganisms without affecting the consumer, adversely. Yeah, so we are already using chlorinated water, and most of these disinfectants actually they just use Jik or Clorox. Yeah, so it is calculated. Yep.
Okay, thank you.
Yep. Any other?
Mine is like I think smaller supplement. I just would like I would like you to brainstorm mass. The way I have seen this freshness maintaining technologies in most of the
The what?
produces. These freshness maintaining technologies in most of these produces. To me, I'm seeing them to be much more quite advanced, quite expensive, quite complicated. To what extent, if you may assess in our country like Uganda have been made that most of the companies have been incorporated them in maintaining this freshness. To what percentage extent can we say that at least we have been realized almost of them are only being attained at the regional and the international levels?
Okay, thank you very much. Now, in this country, most of what you need to realize that most of the fresh produce is consumed locally. I think more than 70% of the produce is consumed locally, and then the 30%, may be exported. So the exporters of this produce, because they are exporting to strict markets like European Union, EU markets, compared to regional. Most of the export markets are just the regional here, where we send our tomatoes, watermelons to South Sudan, to Kenya. Actually, find Kenyans coming here to fail tomatoes and also watermelons and also pineapples. Take them. Then you see, if it is beyond the region, definitely, which is a very small percentage, maybe about 15%, they must be very strict with these technologies. And when you go to these exporters, the serious ones, they are not actually Africans. They are Indians, yeah, who are involved in this. They are, or at least outsiders who are involved in this, and they are trying their level best to maintain this. So it would have been very good actually for us to visit a facility. Let me see, but this COVID brought problems, because in the past, before COVID, we would go and visit. I know there is the Amfree farms, there's Mairi estates. They are doing a lot, in terms of cooling and then exporting. So those ones, like the flower company, of course, they are doing a lot. The flowers are also horticultural crops. They are exporting, a lot of these flowers. But for the food, actually, is, I've got the exporters, but most of them, if they are exporting, for example, to UK, these produce go to ethnic groups there. Like like the Ugandans who are living in London, who are used to consuming matoke, they can actually get the matoke, they can get the beans and whatever. But the real, whites, is rare. So, but within the region, definitely they try their level best to do what? To maintain these conditions, which are, within the region and outside the region, they try very much to maintain these conditions. One reason why these conditions are not practiced a lot, they are very expensive. You can see they involve use of electricity. eh? The technologies are high tech, as we normally say. No, the equipment is rather expensive. So you must really be involved in the real business of export in order to break through. Otherwise, if you are not serious, you are just going to invest in this equipment, and then you end up, making a lot of losses. So in most of these countries where export is assured, that's why they invest in these kind of technologies. Electricity goes on, for example, there is load shedding here in Uganda. It has not been distributed everywhere, so the cold chain is a very poor chain here in this country because of electricity. So the percentage is rather low. The technologies are quite high. High in terms of costs. That's why they are not very much, are practiced in this country. So more than 70%, I believe, of the produce is locally consumed here. But even if, as we consume this produce, let us try to minimize, as I showed you, in one of my slides, this one here. In the absence of this cold chain, temperature management should actually, we can try this to maintain the quality of our produce. Yeah, I hope I have been able to answer you.
Yes, I'm answered. request. Only maybe I may only request for some of these slides if we may get them if possible.
I don't know. I will see. Okay. I will see if I can share some of these slides. All right. So enjoy yourselves. Fazil, please, you need to meet. Let's meet early next week, Monday, so that we talk about the assignment, because it is, the rest of this week, I might not be available properly. So good night and
a physical lecture on Monday.
No, not physical lecture. I meet with Fazil to discuss the assignment, and I need the names, all your names. Okay. So good night.
Good night, Prof.
Yep.
Good night. Think about sharing our notes.
I shared all the notes.
Yeah, you did.
Yeah. Okay. Thanks, Andy. Bye-bye.
Bye, Prof.
Yeah.